Welcome to you in this first lecture of limit of a function. In this lecture we will describe that what is limit and how to find the limit of a function. On the screen you can see a function. The function is f of x is equal to x square minus 4 divided by x minus 2. You can see that this function is undefined at x is equal to 2. For example, if I put the value x is equal to 2, then what we will get? We will get just like it is 2 square minus 4 divided by 2 minus 2, and it will be equal to 4 minus 4 divided by 2 minus 2, and this is equal to 0 divided by 0 form if we put the direct value. Okay, so if we put the approximate value means that the value from the left or the right of 2, then either we will get 0 divided by 0 form or we will get another form. Okay, suppose as you can see on the screen that if I put the value just like I am putting the value x is equal to 1.8. Okay, after putting this value 1.8 in this function, we will get 3.8. Okay, and when we put the another value just like 1.9, then what we will get? We will get 3.9. and if I change the value just like 1.99, then our answer will be 3.99. it's okay. And after putting the next value just like if I put 1.99 and 9, then we will get 3.99 and 9. Okay, so these value will be put in this function. Okay, you can see that these are the value just like 1.8, 1.9, 1.99 and 1.999. you can see that these values are from the left of 2. Okay, these values are approaching to 2, very close to 2, but from the left. Okay, and similarly if we change the values, now I am putting the value from the right side. So what will be the value from the right side of 2? It will be just like 2.1. If we put the value 2.1 in the given function, then we will get the answer just like 4.1. and after putting the value 2.05, we will get the answer 4.05. okay, 4.05. and if we put the value just like 2.001, then our answer will be 4.001. and when we put the value just like 2.001, then we get the answer just like 4.00 and 1. Okay, so we are putting the value in the given function from the left side and from the right side at x is equal to 2. But when we put the value x is equal to 2, then the function is undefined. Okay, and when we put the value from the left side just like 1.8, 1.9, 1.99 and 1.999, and when we put these values from the left side, okay, our answer is not undefined. So what is the answer when we put the value from the left side? Okay, when we put 1.8, it is 3.8, and after putting 1.9, it is 3.9, which is close to 4. Okay, and when we, as the value of x are going to closer to 2, our answer is going to closer to 4. Okay, just like 1.99, our answer get more close to 4, 3.99. And when we take the value close to 2, just like more close to 2, 1.999, our answer is again close to 4, just like 3.999. So as we move close to 2, we will get the answer close to 4 from the left side, and the similar fashion will be discussed on the right side. Just like if we put the value 2.1, then our answer is 4.1. No, we are getting more closer to 2, means we are putting 2.05, then our answer is 4.05. It means that our answer is getting closer to 2. As we are moving closer to 2, our answer is getting closer to 4. Okay, and in the similar way, 2.001 means that we are more close to 2, and our answer is 4.001, which means that we are more close to 4. So as we move more close to 2 from the right side, we get the answer more close to 4 from the right side. In the similar way, as we have discussed, that as we move more close to 2 from the left side, our answer is more close to 4 from the left side. Okay. As the values of x approaches to 2, putting in the function, okay, our answer is getting limit x approaches to 2, putting in the function, we are getting our answer 4. And in more generalized way, we can write just like as limit x approaches to a, okay, and f of x, we will get the limit L. As x approaches to a, which means that x is in between a minus delta. A minus delta means from the left side, and a plus delta from the right side. X approaches to a means that we are talking about x approaches to means that the value of x is in between a minus delta and a plus delta. A minus delta means left side of 2, just like, and a plus delta means that right side of 2. And since we get the answer, so we can write it just like as, okay, what we get the answer? Our answer is limit f of x approaching to L. So this means that L minus epsilon, it means that f of x, the value of x will be in between L minus epsilon. L minus epsilon means that close to 4 from the left side, and L plus epsilon means that close to 4 from the right side, L plus epsilon. Therefore, this can be written as f of x minus f of x minus L, okay, is in between, just like it will be minus epsilon and this will be plus epsilon. Okay, so it can be written as just like f of x minus L is in between minus epsilon and plus epsilon, and whenever this situation is, then we can write f of x minus L mod is absolute value is less than epsilon. And similarly we can write it just like as x is in between just like minus delta x minus a, and this is yes plus delta. So it can be written in absolute value x minus a mod is less than delta. So these two conditions, okay, when x minus a mod is less than delta, then f of x minus L mod or absolute value is less than epsilon. So this is the epsilon delta definition of limit of a function. Remember that epsilon delta definition is always for the finite limit, not for infinite limit. Okay, so this definition works for both. Okay, so this definition works for finite limit and infinite limit, and this definition hold only for finite limit, not for infinite limit. It's okay. I will meet you in the next lecture.